Okay, so this is the two main things that you need to take note for CSTR series, and this is first order. Then for this for page 11, and then second order, you need to take notes of this is parallel, this one, which can be rewritten as that. So this is the whole derivation if you're interested. I mean, like, I'm not really sure if you need to show how you derive or not, because I mean tutorial tak ya. But yeah, okay, anyways. So now tutorial 9. So first question is, so first of all we know that it's a first order, and because elementary reaction, and then after that, first one is you need to find conversion A. So conversion A, PFR, we know that it will fall along this line, and it will fall along that line. Then after that, you need to find your dA, basically your tau k. So you need to find this value, and so tau k. So how to find tau is V over V naught. But we also know that V over V naught can be rewritten as CA naught or V over FA naught. Kan? Okay. So we substitute our values. Remember to check your units because now this one, okay, meter cube, mole per meter cube, mole per minute, then this is seconds. So you need to change either one. Preferably just change your FA naught. Okay. Okay, so CA naught is 1.43. Then V is 12. Then answer divided by FA naught, which is 46.3 times 1 over 60. So 46.3 over 60. Oh. We get that amount. So this amount times constant K is 0.0875. Okay, so you get 1.9, which is basically 2 lah. Just round it up to 2. So this is 2. So this is 2. Then we follow this one down, which is around 0.14. So this 0.14, 0 is 1 minus XA, 0.14. So XA is around 0.86 like that. Okay? So that's how you solve using the graph. And then let's say they say don't use the graph, and because like for my paper hari tu they ask us to use the graph but let's say they want a theoretical method one, you need to show that you derive this. You don't have to show from the first part but wait, must you show from the first part? Yeah, you need to show from the first part. You need to show from this part where apa ni? Yeah, where you derive from this FA naught here. Okay, so you derive from this FA naught here. I'm not really sure if you want me to do, but basically, yeah. I mean, if you need me to explain this part, you just tell me Then I'll take another separate video. Kau tak video ni akan panjang gila. I scared you pun. Yeah, you pun macam lah. But yeah, okay. Then after that, so basically this one you get your tau is equal to this one. This is by default. You need to know that you will get this basically. Okay, because it's inside this thing also yang cikgu kasih tu. Okay, so this is first order. Then you get 86 straight away. Okay, so you tell me if you want me to show that one. Okay, then for part B they state that if the reactor is replaced with an ideal CSTR while the operating parameters remain the same, calculate the conversion A. So remember that, take note that once my tau doesn't change maksudnya my K tau is still the same, because we know that tau is equal to V over V naught. So V naught is always a constant it's always a constant. So the one we will always readjust is our volume. So if our volume over here, they say that dia setakat tukar to a CSTR, it means that and then the other operating parameters remain the same. It means that my volume remains the same. My volume is still the same, my like temperature semua sama. Cause also inside the notes they also state that hold on. They also state that this one. Equal size, it means that my tau is equal to each other, my K is also equal to each other under the same temperature semua. So it means that same operating parameters and everything remains the same. My K tau is completely the same. I just change my reading from my graph. So for this case, the reading from my graph, they say it's a CSTR and so since it's a CSTR, from the graph my K tau is still 2. I read from here straight away. So 0.33. So this is 0.1, 0.2, 0.3 n. Oh wait, hold on. This is 2. K tau doesn't change from the graph for CSTR. Okay. This is my n is equal to 1. It's still 2n. So it's still 2, then I can straight away read ke bawah sini. So it's 1, 2, 3. And I can see that. Wait, I guess it's hot. Okay. So since it's only n is equal to 1, you read from here straight away. And then you can straight away pin down from here down. Okay. So this is 1, 2, 3. So around 0.32, 0.3533 gitu. I mean it's not a straight line lah. So yeah. So based on the answer key here is 0.33. So it means that my XA is 0.67. Okay. So note that if my size all doesn't change, my K tau remains the same. Okay. And then for theoretical method, again, it's actually just the same thing. You need to derive. Okay, so you need to derive from here. And then you work it out till you get this 0.67. Is 0.67? Yes, 0.67. Okay. Okay. Now for the part C, the two identical CSTR of the same volume. Two identical CSTR of the same volume in part B. So this one plus states that is this CSTR, but now there's two. Maksudnya my volume changes to 2V kan. So used in series, all of the operating parameters remain the same. So now it means that I'll be drawing. Okay. Now take note that my tau changes because there's 2V n. So it means that, in other words, tau becomes it becomes V naught n. Sorry. So it becomes 2. So you need to balance this out. This one becomes 2 also. So that's the whole working behind this part. So that's why my K tau prime is equal to 2K tau, which is 4. Because earlier my tau is 2 and like yeah, just now the tau was 2. So now our tau becomes 4 because there's 2 CSTR. Because my volume is doubled. So let's say I have 3 CSTR, then my K tau is times 3 also. Okay. So now for 2 CSTR, it means that since my K tau is 4, I read from 4, which is around here. So here to 2. Okay, and then I pin down. This is 4. This is my 2 and n to 2 down around here. So you can see there's around 0.13, 0.12 around there. So my 1 is equal to XA is equal to 0.12. So therefore my XA is 0.88. Okay. Okay. For second order basically you use the second order punya tu. Only that take note that for second order and second order, it will no longer be K tau. I koyakkan. I don't know where my graph go. Oh wait, it's here. No. So take note that for second order is now KCA not tau. It's no longer just K tau. It's KCA not tau. Okay, but everything else is the same. For my paper, this one came out, so I can just there's a paper with me. Where's the paper with me? Okay, later I see. Okay. So this is the itu. So basically the only difference is you need to calculate ni 3 variable in order to find it lah. Okay, because as you can see all the this one are all the same. This one also you just show your